Okay, so I'll admit that this type of problem is actually one of my favorites. I know that's a wee bit nerdy, but they're just kind of fun. It's not really real world, but it's like a what if kind of thing. And you get to think about real world answers and real world solutions. So you're ordering pizzas and sandwiches. You have a budget of $80. How many sandwiches can you buy if you buy 4 pizzas, 5 pizzas? Explain your answer. So here's the idea. We have to start with those let statements, right? And we're going to say, solve this equation. So 10, oh, that's something you got to know too, I'm sorry. Pizzas are $10 each, sandwiches are 5. This is what we call a mixture equation. So $10 for a pizza, so X, and that's what the thing is missing here. It's missing the statement of let X equal number of pizzas and Y equal number of sandwiches. I would have used P and S as my variables, but that's okay. So again, $10 a pizza, $5 a sandwich, you have $80 total. Things to think about. You can buy 0 pizzas and buy a whole bunch of sandwiches, right? You could buy 0 sandwiches and buy 8 pizzas. Something else. X and Y cannot be negative. You can't buy -3 pizzas. I don't know what that looks like, -3 pizzas. You might want to think about that, but I don't think that it's an appropriate number because it's not a real-world solution. So 0 all the way up to, whatever allows you to, so obviously X can be anywhere from 0 to 8. Y can be anywhere 0 to 14, or 16 rather. So there you go. Anyway, again, literal equations, what we're looking for is finding out how many, I'm going to solve for the number of sandwiches. So in other words, I'm going to solve this equation for Y. Now you think, oh, there's 2 variables. Yes, there are. So I'm going to have to use all the fun stuff I know about order of operations to make this happen. So starting out, we're trying to get Y by itself. So we subtract the 10x from both sides. So I get 5y equals 80 minus 10x. Still trying to get y by itself, so I want to divide both sides entirely by 5. So divide by 5, divide by 5. Notice that yields dividing the entire right side by 5. So y is technically 80 minus 10x over 5, and you can obviously simplify that into 16 minus 2x on the right side. So now we can use the rewritten equation to find y when x is 3. So again, we plug in 3. 3 times 2 is 6. 16 minus 6 is 10. And if I decide, okay, let's buy 6 pizzas. 2 times 6 is 12. 16 minus 12 is 4. So that gives us, again, we can buy 10 sandwiches or 4 sandwiches, depending on 3 pizzas or 6 pizzas. And don't forget to label your answers as well. So again, literal equations here. Okay, so for you, solve the equation 4 equals 2m minus 5n for the variable m. What are the values of m when n is -2, 0, and 2? I'll do that for you here in just a second. So what that looks like, again, I take that 4 equals 2m minus 5n, and we are solving, as we said, for m. So I want to add that 5n to both sides, add 5n. So again, we're just kind of moving everything away from it, reverse order of operations. So we have 4 plus 5n equals 2m. Divide off that 2, again, the entire side over here, so 4 plus 5n over 2 equals m. Now, if the 5 instead were an even number, we'd be able to go ahead and reduce that left side, but we can't, so we have to leave it like that. So now we're going to go ahead and we can plug in a few values, -2, 0, and 2. And so we're going to have 4 plus 5 times -2 divided by 2 equals m. So we ask ourselves here now, 5 times -2, right, is -10. So we're going to have 4 plus -10 divided by 2. Which is on the top -6 divided by 2, which is -3. So again, we would have when n equals -2, m is -3. Let me slide that out of the way just a second. Similarly, we're going to plug in a 0. So we're going to say 4 plus 5 times 0 divided by 2. And so that's going to be 4 divided by 2, which is just 2. And then we're going to say 4 plus 5 times a positive 2 this time, divided by 2. So on the top, 14 divided by 2, which is 7. All right, so that's A. And the last one, it just wants to use the standard way. It wants you to plug in for x a 3 and x a 6, and then go through and solve. And the answers you're going to find here, we're going to have 10 and 4. And the question here really is, do you prefer this method? So it's not, I know you can all solve it, it's do you prefer it? In other words, would you want to plug in, so let's grab this and get this up over here. Would you rather plug it in before you solve the literal equation is what we're really asking. And that's up to you. What do you prefer? Personally, I like solving the literal equation first for a given variable and then substituting. I think it's a little easier. But that's up to you. Okay, so here's the ones that I think are definitely fun. Rewriting a literal equation with only variables. What equation do you get when you solve ax minus bx equals c for x? And what that looks like here. So again, our goal is to solve for x. So you can use your distributive property to sort of undistribute, if you will, right? Pull an x out of both and it comes out to the outside. So we're left with just a minus b inside the parentheses here. And we're going to go ahead and divide off a minus b as a single unit. I would have done this just because, even though I technically don't have to because the fraction bar does create a grouping symbol, but I just like to see it there anyway. It's up to you. Anyway, then dividing off that a minus b as a single unit, yielding c over a minus b is what x equals. So rewriting a literal equation. Alright, so here we're going to solve for x, so I have the opposite of t, and again technically that is read as the opposite of t because you don't know currently if t is positive or negative depending on the value, equals r plus p times x. Solving for x, so I'm going to obviously want to subtract off that r, so the opposite of t minus r equals px. Divide off the p, again make sure you divide the entire left side, so x is the opposite of t minus r all over p. And that's our lovely literal equation there. I've included some formulas for you that I think you're going to find useful. And these are straight out of your book. So formula for perimeter of a rectangle, right? Circumference of a circle, so on and so forth. Obviously, if I'm including them here, I'm going to expect you to have to operate with them. So I've included those because I know that you're going to want them. So the first example here, what is the radius of a circle with circumference 64 feet? Round to the nearest tenth. Obviously, since pi is involved, we're going to do some rounding anyway, so unless we leave in terms of pi, which we'll get to that part later this year, or you should have covered last year probably. So what we're looking for is finding the radius. So I'm going to, in other words, solve this for r. So here is the current. Circumference equals 2 pi r. You all know that. I want to solve for r, so I divide off the 2 pi. Take it off in a single unit if you wish. So r is technically circumference over 2 pi. So if I plug in that 64 for my circumference, divide by 2 times 3.14, so 64 divided by, 6.28, yields about 10.2 feet in this case. So r is about, again, we're rounding here. So literal equations, from actual formulas. I'll bet you didn't know we could make geometry stuff that much more fun, right? Alrighty, so what is the height of a triangle that has an area of 24 inches squared and a base with a length of 8 inches? So what I'm gonna use is area equals base times height. Now there's length times width down here, but base times height, same thing. And obviously you want to solve for height. So I divide both sides by h. I'm sorry, both sides by base. There we go. So area over base equals the height. So we're going to substitute there. I have an area of 24 inches and a base of 8. So my height. So obviously you're going to have 6 is the height. And that answer is in inches. Something I do want to draw your attention to is technically, so I want you to know how the label comes about. Technically this is 24 inches squared and this is 8 inches. They don't just magically go away. Inches squared means inches times inches. On the bottom I had inches. So when I canceled out the 8, right, and when I divide it out, technically when this 24 became a 6, one of the inches went with it. That's why it's called 6 inches, not inches squared. Plus it's linear. But again, I wanted you to kind of note that piece there. So there you go. Rewriting a formula. The monarch butterfly is the only butterfly that migrates annually north and south. The distance that a particular group of monarch butterflies travels is shown. It takes a typical butterfly about 120 days to travel one way. What is the average rate at which a butterfly travels in miles per day, round to the nearest mile per day? By the way, my house was on the my old house was on the migratory route of this, and one time one of my fruit trees was full of just thousands and thousands of monarchs. Very cool thing to see. Alrighty, so distance again obviously equals rate times time. I'm solving for rate. So divide both sides by that t to get rid of it. So d over t is the rate. So we can plug in, right, 1700 for days, 120, I'm sorry, yes, for the distance, 1700 for the distance, sorry. Time is 120 days. So I get about, again we're rounding, about 14 is the rate. And again, that's miles per day because this is miles, this was days, so miles per day is where we get our label from. Alrighty, Pacific gray whales migrate annually from the waters near Alaska to the waters near Baja California, Mexico. A little nicer down there, I think, and back. The whales travel a distance about 500 miles each way at an average rate of 91 miles per day. But how many miles does it take the whale to migrate one way? So we'd already solved in the previous one to know that d over t equals r, right? Well, that's not the one we're actually using here, are we? What we're actually solving is, again, distance equals rate times time. This time I want to solve for t, for time. So this isn't going to do us any good. So we divide both sides by r. So d over r equals t, because these guys cancel out over here. So my distance and my rate, so we have 5,000 miles. My rate of 91 miles per day is what we're looking for to solve for our time. So 5,000 divided by 91, it's like 54.9, I think, right? So it's about 55 days. That's quite a journey. I'd just stay there. A little nicer, a little warmer.